Hi, very good morning to one and all present here. Good morning. Good morning. Yeah, let me introduce myself, Dr. Uma. I'm here to present a topic called FPGA design techniques and introduction to IC. So FPGA is nothing but field programmable gate array. You need not to worry about what is FPGA right now. Once we enter into the session, we will come to know what is FPGA. Okay, so introduction to IC. So in this part, we will see different types of ICs that are available in current scenarios. Okay, so that's the implication of this topic, FPGA design techniques. What are the design techniques? What are the design methodologies available to program an FPGA device? That is FPGA design techniques, and we will see what are the ICs that are available for FPGAs. Okay, so before entering into this topic, let me introduce. So I'm Dr. Uma. I hold my PhD in VLSI. VLSI is very large scale integration. This is a chip design area and electronics communication engineering. And I have my MChip degree in master's degree in VLSI design, a bachelor's degree in electronics and communication engineering. Okay. So currently I'm working as a lead training and development specialist, SmartX Consultancy, Malaysia. So I have a teaching and research experience for about 18 years. I'm expertise in VLSI design, FPGA architecture, digital IC design and EDA tools. And I have been mentoring UG, PG, PhD students, and I'm driving innovation in semiconductor education. And my awards and destinations have been awarded the Best Teacher Award and the Best R&D Award for the year 2017, and consecutively for the year 2006 to 2008 I've been awarded the Best Teacher Award, which is conferred by JPR Engineering College, and I received the Best Paper Award from an international forum, international conference on semiconductor electronics, that's also from Malaysia. Successfully, I've guided nearly 5 PhD scholars, and I've guided 20 MS by research candidate. And apart from this, I have authored 45 international research papers, which have been published in SCI Index, Science Citation Index. And I'm the reviewer for reputed journals like IEEE, Transactions, Springer, and elsewhere. Apart from that, I have authored a book on VLSI, and I have the expertise to this design tools, language, and specialist. So design tools, I'm well versed in Vivodo, Model Sim, Quartus, Xilinx software. So these are the softwares that are for FPGAs. And if you take Tanner, Mentor Graphics, and uh, these two tools are belonging to ASIC tools. And the languages that I have the expertise in Verilog HDL and VHDL, and I'm a specialist in logic synthesis, low power design, high speed FPGA prototyping, RTL design, and verification. All these processes involved in two methodologies, one in the FPGAs and ASIC. So when we progress toward the session, you will understand what is FPGA and what is ASIC, right? So that's all about me. So before entering into the ice breaking session, okay, I'll put a question now. Okay, you think electronics is indispensable? Okay, it is a mandatory component today. Do you agree? Yes. So starting from our mobile phone, the laptop, desktop, the projectors, the AC, automation in industry, uh, in kitchen equipments, everything is incorporated with an electronic device, which is nothing but this integrated circuit, this chip, this electronic chip, right? So this electronic chip is responsible for the pragmatic changes, monumental changes in the electronic fields. Okay, so we'll start with the ice breaking session. So please introduce yourself and kindly tell me some electronic devices that we use day to day. Yes. Yeah. Good morning. Good morning. Any electronic device? Okay. Thank you so much. Any electronic components, electronic device? Yes, definitely. Okay. Yeah, sure. Thank you. Hi. Yeah. So the recent electronic chips that I want to mention is automatic car. Yeah. So inside everything is IC chip. So how we are programming and how we are retrieving the messages and how it is connected to the cloud management system. So these are all the things that I'm interested. Yeah, sure. Hi, my name is Jessica. You could easily say phones and laptops. Okay. And I am Pratako, I use a lot of devices for my day-to-day life, mainly laptops, smartphones. Yes, so I'm keen and I am very interested to learn more on how I can improve, on my usage. Yeah, thank you so much. Hi. It's Adya from Francesco Savesi. Some electronic devices that we use in our day-to-day life. For me, is smart device, smartwatch. Yeah. I am from Smart Face Consultancy. Basically, some of the electronic devices that I use day to day, basically my laptops, my iPads, my phones, my smartwatch as well. Yeah, thank you so much. So I just issue this property. We will be using this in the MCQ. So the red stands for A. Okay. This orange stands for B, and this green for C, and yellow for D. Those are opting for A, you can raise it red color. Opting for B, you can choose orange, green for C, and yellow for D. Okay, so I'll give you the cards. You just pass it. Pass it. Yes, yeah, you can write it. A for red, orange for B, green for C, and all right. So are you comfortable now? Yeah. So now we'll move on to what are the learning outcomes of this presentation or this course, right? So upon completion of this course, you may be able to understand what is the basic concept of an integrated circuit, IC, right? And you understand the basic IC fabrication process. You can able to understand what is FPGA and ASIC design, and you know the fabrication process, the material that is used in ICs, and you can able to differentiate various types of ICs based on its functions and based on the integration scale. And you will be able to identify some commonly used ICs in real world electronics application, and you understand the complete FPGA design flow from specification to implementation, which includes the key stages of a process, design entry, synthesis, simulation, place and route, bit stream generation, and programming. So this is the learning outcome of this presentation. So next we will move on to the session outline. So the session outline, I have formulated 4 sessions. First, we will move on to the overview of integrated circuit. We will see the difference between ASIC and FPGA through some analogies, and we will see the classification of IC, FPGA design flow, and we will conclude the session. Okay. So, all right, we are going to the first session, the introduction part, right? So, yeah, no, this will come afterwards. Okay. So, this is discrete components. Okay. So, whatever electronic devices you use, you can see these components: capacitors, resistors, inductors. Okay. So, capacitor is an electronic device which will store the charge. So, if you take this battery, okay, the battery that we use generally contains this capacitors. So the capacitors are used for storing the charges. Okay. So resistor, this is the component which will resist the flow of current. Right. And if you take this inductor, this is also similar to capacitor, but the capacitor will store the charges, electrical charges, under some voltage flow. If you take an inductor, it also does the same as capacitor. Instead of electric field, there will be a magnetic field. So that's the difference between the inductor and the capacitor. Apart from that, you have one more entity called transistors. Okay, so transistors, which is the most important component used in electronic device, which is responsible for producing current and voltages. Okay, so these are called as the discrete components. This is standalone component which are used in semiconductors. Okay, so suppose if I am making some application using this discrete component, you think you'll have a huge size of device. Okay, if I use standalone component, if I make interconnection with the standalone component, do you think the size of the device will be large or small? Very large, is it? If I use any application using this discrete component, the size of the device will be large. So in order to reduce the size, the technologists evolved a concept called technology called IC, integrated circuit, where all these discrete components are fabricated in a single chip. Okay, so IC is nothing but a semiconductor device which will accommodate which all the IC capacitor, resistors, inductors, everything are compacted or fabricated in a single chip to produce a single function. Okay. Yes, miniaturization. Miniaturization, that we will call it as level of integration. Okay, so this is an integrated circuit. So you think how many discrete components this chip contains? Any idea? Millions of transistors, millions of ICs, discrete components are fabricated in this single chip to perform a specific function. Yes. So millions. So that is called as level of integration, or simply call it as miniaturization technique. Okay, so you imagine that in this IC, the size of each and every individual component cannot be visualized through your eyes. You need a microscope to visualize all the component inside the chip. Okay, so the advancement in electronics is very, very, very high.
Can we say that after every few months from now,
For every 18 months, the fabrication methods, the size of the IC is shrink for every 18 months. That is called as, yes, yes, yes. Currently, the transistor size is 45 nanometer. You think nano is 10 to the power of minus 9. 9. Okay, for every 18 months, the shrinkage of the transistor happens. Yeah, that is Giga VLSI design. So in Japanese technology, they are using this one. Yes, picometers. Yes, we have to achieve. Yeah, this is integrated circuit definition. So an integrated IC, often called as a chip, is a miniature electronic device that combines numerous electronic components like resistors, transistors and capacitor onto a single semiconductor chip, usually called as a silicon chip. These components are interconnected, built upon the chip to perform specific functions or tasks. Yeah? So next we will move on to uh, how ICs are fabricated, right? So the magic material behind this is called as silicon. Okay, normally this integrated circuits are fabricated using silicon material. You know where the silicon material can be found? Normal sand. Normal sand, they will segregate the sand and the silicon. So why silicon? Why silicon? So the other material like germanium is there, graphene materials are there also available, abundant in nature. Why silicon? Because silicon is the material which will have the capability of good conducting and insulating. I will explain what is good conductor and insulator, right?
silicon is closely resembling the carbon, but why silicon still became the candidate in comparison to carbon?
Processing is very simple. It's not complex when compared to other components, other materials. Okay, so what is good conductor? Okay, the element or the component which will allow the flow of current, we'll call it as good conductor. The device which will exhibit or which does not allow the flow of current, we will call it as insulators. Okay, so semiconductor will have the property of good conductor as well as insulators. Okay, so when the device is in off state, the device acts as an insulator. So there will not be any current flow exhibits. When you turn on your device, it automatically sends the current. Okay, so that's why silicon is preferred, and moreover, processing the silicon into a chip is easy when compared to other components. Okay, so I'll play a video. So before that, I'll give you a few introduction how this fabrication is done. So from the earth silicon, the earth crust, from the sand, silicon is segregated. This will be molded into a liquefied form, and there will be an ingot, iron ingot. They will pour this liquefied material into this ingot. So they will allow the crystal to grow. Once the liquefied form is solidified, they will take the material from the ingot, they will slice into as a bread slices, like bread slices, and then they will do lot of process like a diffusion, ion implantations. So normally when you take a silicon, right, it will not exhibit electrical flow because the components will have a intact mechanical orientation. Once you break the covalent bond, once you break the covalent components, then only electrical flow will start takes place. So how this will be done in the fabrication process by adding impurities. Some sort of impurities will be added to the purest silicon so that the mechanical orientation can be changed. Then the current flow will start exhibiting in the device. Okay, so then they, after this doping process, photolithography is, so suppose if I want some content, okay, if this is a very important document, you assume that if I want this document to have 100 or 1,000 pieces, what we will do? No, no, you assume that I have some important document. I want to distribute this document for 1,000 people. How will you do? Yeah, you can take photocopy, or you will do Xerox. Yes, you will take a printout and distribute, right? Similarly, the pattern that should be exhibited in an integrated circuit will be taken as a photolithography. The masking pattern, what type of components, where the resistor should come, where the capacitor should come, everything will be predefined as a mask. Okay, this photo mask will be applied over all the surface of the ICs, and then they will divide the IC into dices. Okay, they will do dices, and they will go for field testing. So in field testing, they will check for the functional test, reliability test, yield test, everything will be carried out. Once this is done, they will do a packaging. Through an hard bound surface, they will pack the IC and send it to the market availability. So this is the simple process that happens in fabrication. Yeah, that's all about the fabrication process. So next we want to why this semiconductor industry plays a very vital role in today's scenario. Okay, so in every country, a huge investment has been done for this IC industry. Okay, so because several growth has been done in consumer electronics, automotive, defense, healthcare, and telecommunication sectors. So we will have a break now for 5 minutes to 10 minutes, then we will resume the presentation. Okay, we will go to an interesting ice-breaking session now. So we will see what is FPGA and ASIC. Okay, so these are the two methodologies available for any product development in electronics. Okay, especially electronic components. So FPGA stands for Field Programmable Gate Array, and ASIC stands for Application Specific Integrated Circuit. You need not to worry about now what is ASIC FPGA. I will explain this concept through an analogy. Okay. So this is an analogy for FPGA. Okay, we will go to a restaurant. So once you enter into a restaurant, you'll see a menu card. So suppose you like nasi goreng, okay, you will order for nasi goreng, right? So you will wait in the dining area. Once the food is ready, they will serve you. You will enjoy the food. You will not accept the taste level. Whatever they give, you will accept it, right? So the time, at what time, maximum time you will receive the order, food, minimum 10 to 15 minutes, right? Because everything is pre-cooked. The rice is pre-cooked. The food, I mean, the vegetables, spice, everything is readily available. Okay, so the time consumption is very, very less. So FPGA is a field programmable gate array, which is a already implemented IC. Okay, I need to write only the application. Okay, I will write the application. So this is an FPGA board. This is an FPGA product development board. This IC is already available. Only thing, I have to write the application algorithm through my system, a language called Verilog or VHDL. I will program it. I will transfer the application into the system, into this chip. Now the chip is ready for that particular application. So this is called field programmable gate array. Why it is programmable means it is reconfigurable. Once, unless otherwise I receive the entire output correct, I can keep on configure this device. Reprogrammability is possible using FPGAs. Okay, so I have a ready-made chip available. Okay, everything is readily available. I will write the program. I will dump the program into this chip. Now the chip is ready for that particular application. Now the turnaround time is less. This is reconfigurable, and this is used for multiple application. For example, if you take your desktop, I can do lot of application using my desktop or laptop. Like I can process Word, I can process Excel, I can process PPT. Other than that, I can perform lot of computation work. Okay, that is FPGA. FPGA is general purpose application, and reconfigurability is available, and you have one more property called portability or interoperability. So that's nothing but, if you take your desktop, there is a RAM slot. If you want to improve your system speed, definitely you'll be adding RAMs, right? So this RAM slots, you can use any vendor's ICs. You can take this IC to next system also. You can plug and play to next system also. That is called as interoperability. That is, it does not have a dependent factor on vendors. Okay, so these are the properties of an FPG. The other scenario we will move to ASIC, analogy of ASIC. Now we are at home. We are going to prepare nasi goreng. All the raw materials will be available in our kitchen. Okay, you have to prepare according to your taste level, according to your requirement, how much quantity, everything will be decided by you, right? So when a product is intended for specific application, okay, for example, this smartwatch. So this is a application of design of ASIC, application specific integrated circuit. So a product which is developed for a particular application. Okay, so this will not do any general purpose application, any other than that. So this will have a minimum of 5 to 6 functions. So other than that, it will not do any processing. Once failure happens, you need to throw away the device. It is not reconfigurable, right? It is not reconfigurable, and this doesn't have the property of interoperability, right? So this is an example for ASIC. The other example is our mobile phone. Okay, so mobile phone is an example of application specific integrated circuit. So a product can be developed with two methodologies. One is FPGA, readily available chip. I can program it, I can reprogram it, and I can use it for multi-purpose. So ASIC, it is application specific, it is not reprogrammable. So once failure happens, you have to throw away. No replacement. Okay, so that is ASIC. So how FPGA programming done? That I have explained already. So through your system, you write the application through JTAG pin. This is the development board. So where I will dump all my codes into this IC. So this process is called as SoC, silicon on chip. Then this chip is readily available now. So the application design time will very, very less. So this is the difference between, so customization is not possible in ASIC side, but in FPGA reconfigurability is available. And the performance, if you take ASIC, the performance is very high, but generally field programmable will be low because it will do multitasking. This will do only specific work, and cost. The initial NRE will be very high for ASIC, and the capital cost will be very less because already the IC is manufactured, and time to market is faster for FPGA and the longer design cycle for ASIC. All right, we are going to do match the device. This is the ice breaking session now. James, can you say this meter, whether this falls under FPGA or ASIC? This one. Yes, ASIC. Because why ASIC? Yeah, this is will do only a specific application. Pramita, this desktop. Yes, very good. I give a star to you. Yeah, this is FPGA because it will perform multitasking, right? And now, Jaswanther, smartwatch.
Seems to be specific ASIC.
Yes, ASIC. Okay. Jay Chitra, can you say this laptop, whether it is FPGA or ASIC? Yeah, very good. I give a star to you. And Jivashini, can you say this is a RAM slot, RAM IC, whether it is FPGA or ASIC? Yes. How it is FPGA? Yeah, this RAM, you have an interoperability. You can insert to any of this device. So it is, and lastly, mobile. Yeah, it is ASIC because it is meant only for specific application. So I think you can understand a better level what is FPGA and what is ASIC, right? Okay, we will move on to some assessment. So what is an integrated circuit IC? A mechanical system used in electronics, a circuit that integrates only resistors, a miniaturized electronic circuit built into a semiconductor, a communication protocol. You show me through your property. Yeah, all correct. All correct. Start to everyone. Ah. Okay. Okay. Which material is most commonly used to manufacture IC? Either it is A, copper, B, silicon. Yeah, it is silicon, right. And what does ASIC stands for? Automated standard integrated circuit, application specific integrated circuit, advanced semiconductor integrated component, analog signal integrated component. Application specific integrated circuit. It's okay. Uh, okay. Which of the following best describes an FPGA? A chip designed for a specific fixed application, or B, a programmable device that can be reconfigured after manufacturing, a device with embedded software only, D, a memory storage component. Yeah, all correct. Yeah. So everyone, I think everyone understand what is FPGA and ASIC. Yeah, yeah. So this is the end of the ice breaking session now. So we will move on to the next topic. Yeah, we will see the safety briefing, fire exit and assembly port. In the event of fire or emergency evacuation, the nearest exit is located at the right hand side. Okay, it's available on my right hand side. Please follow the signage and calmly proceed to the designated assembly point, and do not use the lift, and don't be panic. Okay, so in case of any emergencies, right, don't use your lift, don't get panic. You just go towards my left, right hand side, and you go along the steps. So fire, first aid and emergency contact. If anyone feels unwell or needs medical assistance at any point, please alert me, right? Or any of the facilitators immediately. And if you want any first aid, you just contact the receptionist. In case of any emergency, please do contact this number 0122062552. Don't hesitate for anything. If you feel any type of sickness, if you feel vomiting or any other issue, you just contact to this number, or you can also contact our facilitators immediately, right? It's okay. Next. So the restroom, the toilets are located at the right hand side of the door. So feel free to step out as needed. Just do so quietly, right? So you cannot disturb the class or the presentation side. Okay? All right? All right. General safety and contact. Please keep your personal belongings secure, and the management or we are not responsible for your belongings. So please secure your belongings carefully, right? And refrain from running or engaging in any activity that could lead to accidents. So be patient. Okay, so just to follow the rules and regulations strictly, so that it should not disturb the environment or the presentation, or you people also should not get undisturbed. And we want to ensure a safe and comfortable environment for everyone, right? And medical conditions and allergies. If you have any allergies, health conditions or special needs, we would be aware of. Feel free to let us know privately after this, right? So if you have any problem with the AC, so if you have any chillness that may affect your health, so those criteria can be shared to me or the facilitators available in the receptions, so they can also assist in that cases. So these are the rules and safety briefing regulations. Try to follow this. In case of anything happens, don't get a panic. Everything is available in this environment, and be happy. Please attend the session without any disturbance. Okay? Right. Yeah, thank you. So, all right, we have seen what is FPGA and ASIC, right? So, FPGA is field programmable gate array and ASIC is application specific integrated circuit. So, these are the two methodologies how a digital circuitry can be constructed and how an application can be developed. Okay. So, in the FPGA part, we have seen the device can be reprogrammable, but in the ASIC side, we have seen it is not reprogrammable. Once it is done, that's it. You cannot reprogram or you cannot add on features to that devices. Okay, so it is not a reprogrammable device. And the design turnaround time is also less for FPGA. When you do take ASIC, the design turnaround time will be very large. Okay, so and the product for ASIC is application specific. So it can perform only few applications. Whereas if you take any FPGA, it is multitasking, multi-programmable, multiple applications can be run on a system. Okay, and the process is very simple in FPGA. You need to write coding. Okay, then you have to convert that coding into bit streams because it is a machine. Machine will understand only ones and zeros. So we need to convert into binary format. Through a JTAG pin, we will dump the application. So reprogrammability is multiple time in FPGAs. Okay, so those things are done for ASIC and FPGA. So next we will start with how to classify integrated circuits. So we have seen what is integrated circuit, right? So what is IC? Circuit, it is a semiconductor device where all the discrete components are integrated in a single chip, right, to perform a specific function. So what is the magic material used for fabricating IC? Silicon, because this material will exhibit both the property of good conductor and insulator. Okay, so how are we going to classify the integrated circuit? So you have a lot of ICs. Okay, how to classify it, right? So the classification is generally based on the inputs, right? How are you going to provide, what type of inputs you provide? Based on that criteria, these are going to be divided. Okay, the first one is digital integrated circuit, analog integrated circuit, mixed signal integrated circuit, memory integrated circuit, microprocessors, microcontrollers, and communication IC. Okay, so first we will move on to digital integrated circuit. So before that, we will see the signal classifications. Okay, so for example, in a system, how do you provide inputs? For example, if I'm doing a word, I'm going to type something, right? How do you provide inputs?
Inputs come from our own understanding. We try to
No, no. How do you enter something into the word pad? Word pad. Word, or Excel or PPT. You give some data, right? How do you use keyboard, right? So that is called as an input signals. Okay. So the input signals are classified as analog signals and digital signals, right? So I'm speaking now. Okay, the speak is an analog nature because I can modulate my voice, right? I can slow down my voice, I can increase my magnitude also. Okay, so analog is a signal which have a functionality that will be varying according to time. So all the outputs, okay, that all the inputs that comes from the sensors. Okay, what are the sensors, you know? In the health watch, I have a sensor. Uh, the sensor will observe my BP. This will analyze. So the sensor name is SPO sensor. SPO sensor, and one more sensor available in this which will observe my walking movement. That sensor is called as accelerometer sensor. accelerometer sensor. These are called as analog signals. All signals that comes from nature, the voice, the audio, the video, everything is called as analog because this will have a varying quantity with respect to time. Okay, so those are called as analog signals. So I will give you a chart here. Okay, so this is the time graph. This is my signal, right? So this signal will have a variation with respect to time. So this one. Okay, the peaks will have different voltages. Okay, so this is called as analog signal. So a system, an IC will take only two types of signal. One is analog signal, the other one is digital signal, discrete signals. Okay, discrete signals means I will fix all the quantity with respect to time with two levels. Now you can see the peaks now, all the peaks are uniform. If something presents, the peak exists. If something is not present, the peak value is zero. Can you understand this?
It's just one absolute
Yes, ones and zeros. Ones and zeros. So digital circuitry will accept only ones and zeros. So all the physical quantity are fixed to two maximum level. One is ones, the other one is zero. Whereas if you take the analog signal, it is a varying quantity with respect to time. You can see the peaks. Sometime it exists on the positive side and sometime it can have a negative voltage also. Okay.
also can be somewhere in between.
Yeah, it can be in between also. It can be zero also. Okay, so this is analog signals. So
Continuous value.
yes, it is continuous. Okay, so example for this analog signal is ECG, video, audio, or voice. Everything comes under this analog signals, and the digital signals. This is will have a discrete values.
And you will only send the signal if the value is 1 or 0.
Yes, if something present, we will send it as 1. And if it is something is not present, then we will send the value as 0. Okay, so ones and zeros. So that will have a discrete packets. So normally in a communication sector, we will use only digital communication. We will send the voice. Okay, for example, now you assume that I am in India. I'm making a call to Eddie, okay, to Malaysia. You think how this happens? I'm making a call from India. Immediately you will be connected. I'm speaking something. You are receiving the message. How this happens? How this happens?
Wave.
Yeah, absolutely. You're nearing. So in our Earth's atmosphere, right? You have yes, electromagnetic waves. Electromagnetic waves. So in the Earth atmosphere, you have several frequency zones. They are called as frequency spectrums. Okay, this frequency spectrums are divided based on our, not our government requirements. Okay, so the uppermost frequency level above gigahertz, okay, that is reserved only for military purpose. So that cannot be tracked by anyone. It is a very highly secured frequency spectrum. Below that, we use it for satellite communication. All these satellites can be mounted on the orbit. Okay, so next comes our mobile communications. Below the satellite, the mobile communication comes. Okay, so for every country, the frequency spectrum is divided. For example, if you take for India code, it is +91. Okay, that is the frequency spectrum that is reserved for India. For example, +6, that is reserved for Malaysia. The remaining three codes, that is for area. Suppose +91 94768, that is country code along with the frequency code of that particular area. Suppose if I am residing in Pondicherry, that frequency is reserved for Pondicherry.
That is digital.
Yes, that is digital. Okay, and the remaining 5 is the frequency spectrum that is reserved for individual person. For example, 9787, 898792, the last 5 numbers will have an unique frequency that is not number. As a technologist, we call it as frequencies. Okay, once you make a call, okay, this will be, for example, I will ask you a question. How a balloon can fly? Balloon.
Different organs.
So without any air, it is possible to fly. So you need to blow some air into the balloon, right? So whatever I speak, it is modulated. That is, it is converted into high frequency signals, first of all. Okay, that is called as modulation. It's clear? So because I'm talking from India, you're hearing my voice. How this happens? Because the modulation should be kept under that frequency, high frequency range. So our voice will be modulated with high frequency signals. So these modulations are done using digital technologies. So all the messages, whatever we communicate, are converted into packets, ones and zeros, ones and zeros, ones and zeros.
In that case, doctors, we have multiple, countless layers of spectrum.
Yes, multiple layers of spectrums. So, because a digital communication is very fast when you compare to analog, because analog signals cannot be modulated. It cannot be modulated for high frequency range. Okay, so only digital communication is possible because you can modulate according to the frequency ranges, according to the desired frequency ranges. Because all our mobile communication will work for gigahertz. Okay, so you think that much loudly I will speak up to 10 to the power of 6 gigahertz. It is not possible, right? Whatever I speak, that should be modulated according to the frequency range, and then it is transmitted. How it is transmitted? Everywhere they will have a base station. Okay, so in the base station, you have a network routers. So the network routers only identify from which frequency spectrum it is received. For example, I'm calling from +91 from India, and it will analyze to which frequency it should be converted and it is forwarded to. So it will absorb +6. If it see that frequency, then the router will connect automatically to the base station of Malaysia. So here you have Maxis, right? You have lot of network provider. So if someone is using Maxis, then that will be established to that Maxis network, and then from there you will receive the information. Okay, this will happen in a fraction of a second. It will, this process will exhibit in a fraction of a second. Very minimal. The delay is very minimal. Other, in the previous time, we use frequency division multiplexing. Okay, so when we speak from India to Malaysia, uh, after some sort of delay only you can able to recognize the voice. Now everywhere it is orthogonal frequency division, and CDMA technologies are used so that the communication process can be exhibited in a fraction of a time. So the technology evolves day by day. How happens? Because of this electronic IC. Okay. Yes. Yeah, less delay, and moreover, everything is digitized. Everything is digitized, and every informations are transmitted in terms of digital outputs and receives digital inputs. Okay.
Analog signal still applicable in this model?
Yes, there will be some converters. There are some ICs, whatever we speak is analog in nature, right? That will be converted into digital. That is A to D, analog to digital conversion process.
It is still important to learn analog equally as digital.
Digital equally. right? By nature, analog signal is the one existed. By nature, all analog. So all nature associated signals are analog in nature, but especially for data communication or satellite communication, all the packets are sent in terms of digital ones and zeros.
So it means that even though now we have digital signal, analog signal did not get outdated. It's still equally
It will be there. Without analog, nothing is possible, but internally we will do conversions. Internally we do conversions. So this is analog and the digital signals. These are the two types of inputs that can be applied to this IC as an input, right? So first we will move on to digital integrated circuit. So these are the types of IC which will accept only digital inputs, okay, and it will process only digital input and produces only digital output, right? So I think most of us know digital electronics, right? Yes. So you have a AND gate, OR gate, NAND gate, you have comparator circuits, you have shift registers. So everything falls under this digital ICs, right? So this is the IC that will get the input as a digital input and process the digital data and produces a digital output. So these are some few examples for digital IC. So let's have an analogy for this, right? So, okay, we will see how this digital calculator works. Okay, I have a digital calculator also. So everyone use this, right? So how this works, you know?
from my understanding, all the numbers are converted to the base of 2. So which binary 1011 everything. So calculator will be reading that only. Calculator don't understand beyond that.
Okay.
So
You're closely correct. Okay. So you're closely correct. So as you see this digital calculator, these are called keys. Okay, keyboards, and you have an on off button also. What is inside this IC? What is inside this IC? We will so yes. Can you see this? Yeah. This is a digital processor. This is a digital processor. The circuit realization is very simple for this circuit, right? If you need a keypad, okay, you need a key sensor, okay, you need a key sensor, of course, on off button, display button, and a processor. Okay, now a processor will take only digital information, right? So there is a sensor called keyboard sensor, right? Now listen, that is called I'm I'm giving an input. I'm giving an input. Okay, now I have given 0, or you assume that 55. My input is 55. Now, what happens? This keyboard sensor, basically it is an analog sensor. All inputs received by a sensor will be in analog nature because the press action will have a key bounce. Okay, that key bounce will be recognized by this key sensor. How it recognizes? It will check from which row, from which column the key is being pressed. Okay, so that information will be taken by this key sensor, and this sensed data will be encoded. Encoded is the process of conversion of your analog input into a digital input. Okay, this will convert to ones and zeros. Okay, and this information is given to the processor. So the main task of this processor is it will receive the data, it will wait for the command, what the command is received, and it will execute the instructions, execute the command. For example, my inputs are 55. The 55 will be sensed by the keyboard sensor. That information will be taken by the processor. It will wait. The input will wait, the processor will wait for the next data to be entered. Now I'm giving plus. I'm going to do addition operation. That is the command here. I want to do A plus B. Plus is the command I'm initiating now. So the next data is 45. I'm providing 45. Now this is also converted by the keyboard sensor into binary data, and then it is given to the processor. Once I give this equal to sign, now the command is executed by the processor and you will get the result as 100. That will be displayed in the display unit. So before this conversion, you need to do decoding process. Okay, so internally the processor will do the decoding also with this special IC. Okay, because the output of this processor will be in digital in nature. But whatever data that is available on screen is a readable format. You never understand what is 10101000 unless if you are a technical person. Okay, otherwise you should know the data, which data I'm receiving. So the end process, you have a decoding. Okay, very simple process. That's it. So you have a digital processor here which will accept digital information through your keyboard sensor. So the keyboard sensor in turn receives the input from your keyboard by analyzing which row and which column the key being pressed, and that information will be encoded, which is understood by your computer or your processor. Okay, decoded, and it is given to the processor. So after the processor main task, it receives the information, process it, executes the command and give back the result. So before giving back the result, there is a decoding process. Okay, so this is the simple application how a digital calculator works, right? So for any doubt? Yeah, very clear. Thank you. Thank you so much. Next, we will move on to analog integrated circuit. So we saw previously the digital IC, which will accept only digital data, process only digital data, and provides the output digital output. Reverse of it. So this IC, right? This IC will receive only analog information. This can take only analog information, and you can do processing. Output will also be in analog. Both input and output will always be in analog. Okay, so let me give an example for this. Okay, so everyone will be using our lift, elevators. Yes, right? Elevators. I think so. It is elevator. Right? Lift, lift, right? So how this works? So because everywhere, knowingly or unknowingly, we are living with electronics. We are living with electronics, right? Uh, have you think of it? How this device is working? Because we put commands into it. Yeah, correct. It processes, it puts on until the next command is placed into it, and then it delivers an output. Meaning we proceed to the destination.
Input, process, output.
Yeah. I will tell. Yeah, yeah, correct. I'll give you a star. Okay. So when you press something, okay, that is manually we are doing it, right? So that is an external source. Okay, that external source is analog in nature. Okay, so whatever input that you give, that is a stable multi-vibrator. The inside that press key, no, there is an IC called a stable multi-vibrator. This will triggers a long beep. This analog, that is called as a transducers. Whatever we give as the external input, that will be converted into electrical signals. We will press it, right? We will press, that is analog. that that press will be absorbed by the transducer. So that transducer will convert the mechanical action into electrical signals. Though that electrical signals will be received by this ICs. Okay, so this IC will convert the analog input into digital. Okay, so then it will give to the command given to the processor now. Can you able to understand? Yes. Yes. So whatever input we provide, that is in analog in nature, internally you have a transducers that will convert the mechanical action. What we are doing is a mechanical action now. So that will be converted into electrical signal, though that electrical signal will be in analog nature. So inside this chip, this will convert this into a command in terms of digital, and that will be given to a processor. Now, the processor will have the knowledge or intelligence. So, from where this signal is being received, okay, from which floor it is received, and it will check from which floor to which floor it should be, which it should have a transition. Okay, so those intelligence will be programmed by us. Everything is programmed by us. Okay, so according to the program, the circuit will operate. So internally, there is a processor, digital processor, or it is also called as microprocessor. Okay, that will takes the command, and it will understand the command, then it will execute. So which floor I have to go, which floor I have to come back. Okay, so those intelligence thing will be taken by the processor. So the analog integrated circuit will receive the analog signal and will output the analog output. Okay, so example for this analog integrated circuit is operational amplifiers and voltage regulators, right? So definitely we will use this voltage regulator in our house. Uh, Otherwise it is called as voltage stabilizers. Stabilizers, right? So yes, inside this you have a chip. So yes, inside that we'll have. So stabilizer is a circuit which will give you a stable input or output to the fridge, or you can tie up with the washing machine also, and even. Eh, so this is a name of the IC. 7805 is the name of the IC which is used in voltage regulators. Okay, and 78, so different manufacturers are there. Okay, so there are a lot of manufacturers like Intel, National Semiconductors. uh, in Malaysia you have Broadcom is the company which is in Penang. They do this analog ICs. Broadcom.
And the size of analog IC is considered larger than digital, right? From the size perspective.
The size may differ, depends upon the application, how many number of pin requirement, how many number of output requirement.
Out of curiosity, what's the size? Is it equal to thumb?
Yes, it will be thumb size. It will be in thumb size.
The digital one is getting smaller.
Yes, yeah, it's getting smaller. So that's all about analog integrated circuit. So you understand? If you have any doubt, we will discuss, or we will move on to the next presentation. Yes. Yes, yes, both. So this is a typical example for audio amplifiers. So you can also see in your mobile phones, right? Suppose if you want to mute it, or if you want to raise the volume, right? If you want to decrease the volume, you need an analog IC, right?
It means that devices that have analog circuits will have, you can never go into a minuscule size device. There will be a cutoff point until what size the smartphone can shrink.
Yes.
It cannot shrink beyond that.
Yes. Until now, the protocol is like that. Yes. So this is an audio amplifier which we are using in our computers, we use in the laptops, desktops, and even in mobile phones. This circuitry is responsible for raising the volume, decreasing the volume, everything. Okay, so this is the application or analogy for this audio amplifier, right? All right, we will move on to mixed signal. So almost, you take any application, everything is mixed up. Okay, so previous analogy shows everything was independently working, right? So in a mixed signal integrated circuit, so this is an IC which will accept both analog input as well as digital input. Both can be processed by the processor, and this can be producing the output either in the form of analog or digital. Okay, so in the previous slide you have seen analog digital integrated circuit will receive only digital data. It will process only digital data. Output will also be digital. Okay, so in the analog integrated circuit, inputs are also in analog, processing the data will also be analog, and the output will also be in analog, right? Next, the mixed signal integrated circuit will receive both inputs. It can able to process both the inputs, analog inputs or digital inputs, right? And the output can also be produced in terms of analog or digital, right? So example of this circuitry is Texas Instruments. Okay, so analog to digital converter with I square C. So I square C is nothing but inter-integrated communication protocol. Okay, so for example, I will tell you one example. Um, okay, I will take this laptop. Okay, so suppose I'm receiving WhatsApp video, or I'm going to use any YouTube video I've downloaded. Okay, suppose if I am going to process it. Okay, so processing can be done using this processing can be used using this analog to digital converter, because I said all the natural signals are analog in nature, right? So video falls under analog category. So if you're going to process this video data, then you need an analog to digital converter. Okay, because I'm going to transmit this YouTube video between Jabashini and you, Pramita. Okay, so what I will do before sending it, I'm going to compress the video. How this compression can be done? I'm going to reduce the bit sizes. Okay, so there is a IC called Kodak. Okay, Kodak, CODEC, Kodak. That is the IC which is responsible for reducing or compressing your videos or audios, everything before transmitting to other devices. Right. So I'm compressed. I have converted the signal to A to D, ADC. So how I'm going to transfer? So there is a medium called inter-integrated communication protocol. So that is an IC that is available in all the devices like mobile phones, our laptop or desktop. Through this inter-integrated circuit only you can able to transmit. It is a medium where it facilitates communication between two. Okay, so this is an example for this ADC along with I square C, right? So other than that, you have the reverse process can also be done. That is analog to digital. So analog data is converted to digital, and vice versa is digital to analog conversion. Both can also be done.
Our laptop is a mixture of analog,
Yes,
digital,
yes,
and also mixed
yes,
signals.
mixed signals, right?
Otherwise, we will not be able to compress our data.
Yes. So, and microchip. So you have this ADC as well as SPI interface. So SPI is serial peripheral interface. Okay. So I'll give you an example. Suppose if I'm going to transmit a bulk data, okay, that is called as parallel communication. So at a time, I can transmit 10 or 15 datas at a time. Okay, that is called as parallel communication. This I square C supports parallel communication, right? So SPI is serial communication. This communication will be slower. I will transfer information bit by bit. Bit by bit means in terms of digital data, ones and zeros, 10, 10, 10. I can transmit single bit at a time. Okay, so where it is used, where it is used. So definitely in the communication sector, whenever I'm transmitting a data, right? So I have to ensure whether I'm sending a correct data or not. Okay, that ensurity can be attained using this single bit through this SPI interface. Okay, so whether I have sent a correct data. If yes, I will attach a parity bit called 1. So on receiver side also, if you receive the same data 1, there is no collapse or any packets it's not lost during communication side. Okay, so those type of information can be sent through this SPI interface, serial peripheral interface. Okay, so any doubt in this? Clear.
So for every software,
Hmm.
it must be, we must ensure that there is hardware behind it that integrated to accommodate the software.
See, without hardware, nothing is impossible. You cannot develop any development in softwares or anything. So the brain, the heart of a computer or heart of any electronic device is IC, integrated circuit. Okay,
So
so
when software is developed, they must make sure that it fits all the integrated circuits requirement.
definitely, definitely, because if you take Mac, that OS cannot be supported for Intel. This if you are using this Intel board, the OS cannot be supported. Okay, so for Mac alone, they will use different software.
What kind of data that is being interpreted by all these chips? Is it same with binary too?
Definitely binary. So in the high level programming, we will use Python for OS development, or you can sometimes you can use JavaScripts also for OS development. For higher version, they will combine C++ and Python programming. Okay.
Python programming is very important.
Yes, it's very demanding, and you can develop a lot of embedded applications via Python programming also.
How difficult it is to learn Python?
See, nothing is difficult. Nothing is difficult unless otherwise you have to take the initiative. You should be motivated, right? So always as engineers, always as a human being, we should know why this happens. You have to question yourself. You have to question yourself why this, how this device operates, what mechanism happening inside this IC. So then only question arises, then only solution comes. Is it?
Like robotic hand is famous with the Python language.
Yeah, you can program it via Python, or you can use a hardware description language also. Yes, we will discuss what if.
Like Python, we have Python library, it's just arranged.
Yeah, you can collect from the Python library also, but the coding is not optimized. So if a product is being developed, you have to apply your optimization, not machine optimized. So because many of them are using AI, and they will getting the applications code from AI, but I will say those codes are not optimized one.
We still have to
You have to sit.
design it
Yes,
ourselves.
yes, then only you can develop your thinking capability, and you can develop in an optimized way, the product development in an optimized way.
It's not merely copying and pasting it.
I never encourage this. This is a typical example for washing machine because we use this in day-to-day life, right? So a washing machine, we will program it, right? So all the programming will be done using a sensor. So this sensor data will be converted to analog to digital data, and this is given to this mixed level signals. So this processor will get the analog as well as digital data, and then this will do the functions of monitoring the water level, the speed, motors, and how the washing takes place. So every decisions will be done by this processor. Okay, so finally, yeah, finally, this will give you a beep sound once the process is done, right? That is also in analog nature. I give input in analog, processing will be done in digital. At the end of the session, at the end of the end process, you will receive a beep sound indicating that I have done my work. You can take your decision. That's analog. That's an analog image. Yeah. All right. Next, we will move on to memory integrated circuits. Okay. So memory integrated circuit, these type of ICs will not do any functions like washing machine. We saw washing machines and we saw digital calculator. Rather, this IC will store informations alone. Okay, this is the IC which is used to store data and to retrieve data. Okay, this will do only storing and retrieving data. Other than that, it won't do anything. So whether this IC is an analog or digital, yes, digital as well as you can use analog ICs also. Okay, so if you take Intel, this one, no, K4B2, this is the IC name. Okay, this is an high speed RAM. Okay, so this can store the information in terms of analog also. How it is stored? Using a capacitor. Using a discrete capacitor inside the IC, you can store. Or you can use a transistor called MOSFETs, metal oxide semiconductor field effect transistor. So this is a kind of a device which will store the information in terms of ones and zeros. So you can select whether my configuration should support to the data to be stored in analog nature, or I can store it in the digital form. Okay, so the memory integrated circuits will have the functionality of storing the data and retrieving the data. So clear? Yes. All right, we will move on to a microprocessor, right? This processor is called as the heart and brain of your computer. Okay, so this will do a multiple tasking. Okay, so whether microprocessor is an FPGA product or ASIC product, microprocessor. So this is an IC that is used in your laptop, desktop, FPGAs. Okay, so this will do multiple work. Okay, so listen. So microprocessor, why it is called as micro means each and every instruction commands, it will operate it at the 10 to the power of -6. The speed of the processor. That's why it is called as a micro. It will receive the data, executes the command at the rate of 10 to the power of -6. That's why it is called as a microprocessor.
It's not the size actually,
It is a speed. Okay. Yeah, it is a microprocessor. So it is the heart of our computer, brain of our computer. Without this IC, this laptop is nothing.
So do you call this as motherboard?
Huh?
Is this considered motherboard?
Uh,
This motherboard.
Motherboard. Yes, motherboard. Yes, motherboard. Okay, so motherboard, you have this IC. Okay, so this is a digital IC. It is a standalone IC. Microprocessor is a standalone motherboard IC which will accept digital data only. Okay, this IC will be associated with memory ICs. The previously we saw the memory ICs, right? So it is externally connected through the memory ICs and externally connected with your input output device and externally connected with all the conversion factors like A to D or D to A, analog to digital converter or digital to analog converter. So microprocessor is a specific device which will accept only digital data, process it and produces only digital output. Okay, so all the peripherals are externally connected to the motherboard. If you have opportunity to see the motherboard, you try to see, because with this processor only, all the standalone devices will be connected, right? So, so this is see Intel Core i7. So I think all our laptops will have this Intel i-Core, their motherboard, right? And ARM processor, ARM Cortex-A series, AMD series, those are called as motherboards. They are called as a microprocessor because the execution relies at the speed of 10 to the power of minus 6, right? Now we will move on to microcontrollers. Okay, even this microcontroller will operate at the rate of 10 to the power of minus 6. Okay, but here the microcontroller will work for both analog and digital data. How? Because this microcontroller internally have all these features: A to D, DAC, IO device, memory device, CPU, RAM, all components are integrated in a single chip. Microprocessor is a standalone device which externally connected with the other devices. But a microcontroller is a single chip which contains all these features. So which can perform the operations of analog as well as digital. So where this microprocessor is used, where this microcontroller is used. So if you are going to perform multitasking, multiple applications, then we will have microprocessor. When you have embedded applications, something to do with um, um, analysis work, okay, so to do some specific task. For example, if you take washing machine, the IC there is not processor, it is a microcontroller, because it has to process all the data, digital data, analog data, everything clubbed inside it, and it has only fewer applications. It can wash, it can spin, and it can rinse. Okay, few applications, right? So those few applications can be carried over to microcontrollers.
Every
Okay.
engineering device must have microcontroller.
Yes,
I mean, machineries, everything.
all automations will have this microcontroller. Our microwave oven, that contains microcontrollers, because it has only limited for normally, if you take a microprocessor, this device, the programming or the OS, right, this is called as operating systems. In microcontroller, the operating system is called as RTOS, real time applications. Okay, RTOS, real-time operating system. Because why it is called a real-time operating system? Because all the intelligence or all the decision making has to be done by the processor at real time. Okay, that's why it is called as real-time operating systems.
I'm a bit curious. You have been mentioning Texas Instruments in few slides.
Yes.
Is it that these specializations is only can be done by Texas Instruments company? Or is it that Intel have their own specialty developing certain devices, chips?
Yes, So if you take Intel Corporation, they are very much keen into microprocessor, because every generations will falls on every 18 months. So previously we had Intel iCore 13 processor. Now it is advanced to 14, 15, up to 17 processor. Yes.
Meanwhile, Texas Instruments, they are developing different kind of chips for different purpose that doesn't seem to be mastered by Intel, who it seems to be quite specialized.
Yes, so every ICs cannot be done by an independent manufacturers, right?
So one manufacturer cannot master all.
All, yes. So Intel, if you take, they are specialized in developing motherboards, microprocessors. So Texas, they are very much into ADC, DAC, and microcontrollers.
So that means that there's a lot of, it has many chips manufacturers from
Different. That's why I said it is an FPGA product, because that have the portability and interoperability property. Because multiple vendor ICs can be supported in a single design.
So where does all this merging of these pulses happens?
With the motherboard and associated circuitry.
So like Acer is the one that is responsible for compilation of all these puzzles we're doing every.
Yes, yes, yes. Finally, communication IC, right? So these are the ICs which are used in communication sectors, especially in satellite communication, especially in mobile communications, okay, long distance communications. So previously we used short communication application through wired communication. Before mobile communication, we used wired communication. So you can use your mobile phone inside the particular country. So everything will be plugged via wires. It is not wireless, right? So after that era, we come to an mobile communication, satellite communication. All the information packets are transferred via wireless. So everything is, so if you think around this environment, lot of packets are being traveled, right? Lot of packets, informations are being, that we cannot visibly see this, right? So the communication IC protocol, so this is a modem IC. This IC is called as a modem IC, and this is used for GPS signals also, global positioning systems. Excuse me. So the IC that is used for communication. So now you say what type of IC, whether it is a mixed or analog or digital?
It's mixed.
Yes, it is mixed because yes, we are going to use both analog and digital. So it is a mixed IC. So this is an analogy for communication protocol. This I have explained earlier. So, so this is a mobile phone. So where I'm going to communicate is an analog. So in the frequency spectrum, the informations are transferred in terms of packets. Okay. Now this is this scenario. No, this one. This one is the component that is inside our mobile. Okay, so now I'm talking, right? So that is analog nature. Now this should be converted to electrical signals through some transducers. Now this electrical signals are transmitted via a transmitter. Okay, now this transmitter will convert the packets, digital packets, okay, into electromagnetic waves. So all the informations are now transferred to this EMF. At the end side, I will receive this electromagnetic wave. Now this will be received by a receiver station. So that is inside our mobile. Okay, so the receiver will receive this electromagnetic wave. Now this electronic signal is again converted to analog, because you cannot because because the nature should be there, no? So the analog information should be received, right? Now this is the process that happens in the mobile network. Okay, now I'm making a call, so it will see the frequency spectrum. So which country, which zone, and which frequency is this? So now this will be received by the base station. So suppose you are making a call from India, the call will be connected to this base station India. Okay, now this will be routed, okay, to the mobile switch, via mobile switch, to, to which station it should be transferred, which country, which frequency, all decision will be done by this mobile. See, each and every node, every segment will have an electronics here. Electronic components plays the role. And seeing on the frequency range, suppose if it is +6, then automatically connected to the base station of Malaysia, and then it is transmitted to mobile, the end user. Okay, so this is how this is happening. And so this is the internal block of our mobile. Okay, so our mobile contains, right? So this is some analogy for this communication IC. So internally you have a device called the duplex. Okay, so this is the circuitry IC which is responsible for transmitting the data, receiving the data. It can be done both. I can transmit or I can receive both the data. So that is called as a duplex IC. Okay, so the duplex IC can be receiving the data here. Suppose if you want to send data from my phone, my voice. Okay, now this is given to a codec. Codec is a device which will do the compression. Okay, this compression, and this is called as a mobile station monitoring device. Okay, MSM. So this is otherwise called as a network IC. So this will process the data. Now this will given to a baseband to IF. So baseband is our raw data that should be converted to high frequency signals, because our voice cannot be transmitted to the X space, right, frequency. So it should be converted to IF, intermediate frequencies, and then it is given to the transmitter section. From the transmitter section, the data is sent via the duplex. Duplex will send through the antenna. So every mobile, okay, every mobile internally have this component. Every mobile will have this internally, this component. Definitely a transmitter and a receiver, that is via duplex. So whatever information you speak, that will be compressed, converted into high frequency signal, and it is transmitted via duplex. On the end side, if you are receiving information, this will be received by the RF block. Now this high frequency signal, because it is you cannot hear that high frequency signal, it should be converted to the base signal, that is audible signal, which can be heard by us human. Okay, this high frequency signals will be compressed, or it is eliminated or removed from the thing, and it is given to the end user. So this is the process happening in the communication. Okay, so far we have seen seven different categories of ICs. One is digital IC, so which will process only digital data. And the second one, we have seen the analog IC, which can process analog data, and we can able to differentiate what is digital data and analog data. So analog is continuous with respect to time, and you have a lot of modulation, peaks, everything. When you take a digital data, it is discretized, so you have only two levels of information, either it is one peak or zeros. So mixed signals, so this is the processor where you can use both analog and digital. And then we have seen um, microprocessor and microcontrollers. The difference between microprocessor and microcontroller: a microprocessor is a standalone device. Okay, and microcontroller, you have all the supporting ICs inside a single chip. Then we saw communication ICs. So example, we have seen a mobile communication also. So we will go to the next level of integration of IC fabrication. Okay, so what is level of integration? So level of integration means how many number of discrete components can be accommodated in a single chip. That is called as levels of integration. Yeah, I think before this we will go for a break. Yeah, sure, we will go for a break. We will resume in another 10 minutes. All right, we'll move on to the recap of the presentation. So initially we saw what is an integrated circuit. We started with integrated circuit. So it is an electronic component or a chip which contains discrete components integrated in a single chip to perform some applications or any task. And we have seen what is a discrete component is. So we have seen what is a capacitor, resistors, and the inductor, what is its functionality, everything. And then we defined what is an integrated circuit and what material is used for this IC. So as we talked, silicon is the material that is used for the integrated circuit. Because why? Because why? Why in IC silicon is used?
Because it is right.
So it is the material which exhibits the property of
Induction and also
in, yes, good conductor and an insulator, right? So, and we have seen on a video, how watched a video how this IC is fabricated, and we will see, we have seen the potential requirement. So in Malaysia, nearly 30 billion ringgit has been invested in the expansion of IC fabrication, especially in testing, assembly, and packages. And one more company has also invested 8 billion ringgits in Fionen. The company name is Infionen. So they have also invested a huge amount for the manufacturing setup. Yes, it is in Penang as well as in Malacca. It's in Malacca, and especially if you take Penang, it is called as the Silicon Valley of East. And we have seen the growth rate also. So this is the semiconductor growth rate in Malaysia. This is the export value. This is the graph shown for the year 2015 to 2014. So there is a linear progression. Yes, in 2019 to 20, because of COVID, no export was done. Okay, then after 20, the progression is linear every year. The IC manufacturing, testing, assembling, every process was increased linearly, right?
Is this due to the global demand of chips?
Definitely global demand.
What makes the global demand goes up?
Because everyone know without a mobile, whether it is possible nowadays, everyone has a mobile without any communication, because mobile communication, satellite communication, home appliances, and moreover the cost, everyone will get, because everything is affordable now. The cost is not a constraint, and moreover, all the electronic components available nowadays are less cost. So demand increases. So as demand increases, manufacturing is also increased. Export will also be increased.
We are flooded by chips in every single component.
Yes, in every component is incorporated with electronic ICs. Okay. And so we have discussed what are the top 15 fabrication company. So the first topmost company is Taiwan, that is TSMC, and AMD, Texas Instruments, and this is the Broadcom company, which is in Malaysia, and one more company, I think Broadcom, AMD. This both companies are there in Penang and also in Malacca. And these are the leading top companies like Samsung, Hitachi, Sony, Tesla, Motorola. So these are the companies that they are specifically manufacturing this ASIC, mobile processors. Okay, so
In Malaysia, our focus is more to FPGA and
more towards FPGs, because it is getting imported, right? So they can, so they the imported, I mean exported quantity can be get to the other countries. They will develop the applications and they can use it, because India like country just now they have started up. So they are lot of requirement for FPGA ICs.
how about ASIC? Which country you are focusing more to ASIC?
Japan, Japanese, Japanese and South Korea.
But is it picking up in Malaysia also? ASIC?
I think not now. Maybe in the future.
Coming soon.
Yes, coming soon. Because right now they are into FPGA development.
But it's also a must-have knowledge. Then we can complement each other.
Yes, definitely. And these are the current positions in IC industry. So this three category we have already seen. So in the design and development side, we have analog design engineer, digital design engineer, ASIC engineer, FPGA engineers, embedded system design engineers, verification engineers. So this verification engineer's task is to perform testing. Okay, and the layout engineers, as I said earlier, the photolithography process, right, masking process, this will be done by this layout engineers. And EDA tool development. So for ASIC we will use this EDA tool, electronic design automation tool. So this development will be done by this developers, EDA tools. And IP is nothing but intellectual property design engineers. So these are from design and development side. And in the testing and validation, you have test development engineer, ATE, failure analysis, product test engineer, reliability engineer, and post silicon validation engineer. So these are the job availability in IC industries right now. And we have seen what is an FPGA and the ASIC. So FPGA stands for Git Array. And ASIC stands for? Yeah, very good. So FPGAs are only reprogrammable device, and ASIC it is not reprogrammable, and the turnaround time for FPGA is very minimal. Around it will take 4 weeks. Maximum it will take 4 weeks, and for ASIC it will take years. It will take years.
Turnaround is that is the relevance of the product.
Completion of application.
Completion.
Of applications. And we have seen the analogy of FPGA, so and ASIC also. And we have seen how an FPGA product is developed, how it is programmed. So in your system, you use a development language which is called as Verilog and VHDL. So these are the two standard language available for developing an application for IC. Once this programming is done, once the application is done, we will convert the application into bit streams, and this bit streams is dumped inside this IC. So then on, the IC becomes an application. Now it is ready for market. Okay, so this process is called as SoC process, silicon on chip. Okay, silicon on chip. So next we have seen what is the difference between FPGAs and ASIC in terms of reconfigurability, and we have seen the performance issues also. Normally ASICs are high performance, and the FPGAs are slower. And cost wise, ASIC development will be very higher, and for FPGA it is only minimal cost. And the time to market, it is fast prototyping, and it will take longer design fabrication cycle. And we have done the ice breaking session also. So we have matched the devices according to whether it is an FPGA or ASIC, and we done an MCQ also, and most of them have get stars, right? And we have seen how to classify the integrated circuits. So what is digital integrated circuit, analog integrated circuit, mixed signal memory integrated circuit, microprocessor, microcontroller, and communication IC, using analogies, how an electronic device are classified, whether it is a digital IC or analog IC. So, and we have seen what is a digital signal and analog signals. So, analog signal, which will have a varying quantity with respect to time, so which will have different peaks. The peaks are not fixed, it is varying according to the time. And we have seen all natural signals are called as analog signals. So our voice, our audio, video signals, ECG signals, everything falls under analog category. And next we have seen what is digital signal. So the all inputs are tied to a limits or maximum value. It can contain only a maximum or minimum value. So maximum value, it can be a logic 1, or minimum value, it is called as logic 0. So where this digital signals are used in digital communication, almost all communications, either it is satellite communication or mobile communication, this digital signals play a very critical role, right? And we have seen the definition for digital integrated circuit. So this is an IC which will accept only digital input and process digital data, produces digital output. And we have seen some analogy using this digital calculator also, how this works, and its functional description, everything we have seen. And what is analog integrated circuit? So this is the IC which will accept only analog data, and which will process analog information, produces analog output. And we have seen an analogy of a washing machine and this audio amplifier. Next, we have seen this mixed signal integrated circuit. So this circuit will accept both analog and digital data, and it will process the data, both the data, and produces both the analog and digital outputs. So the analogy that we have seen is a washing machine, how an input can be provided in a washing machine, how this will process, what is its functional description. So everything was discussed in this analogy. And we have seen what is a memory integrated circuit. So memory integrated circuit will not perform any specific task, rather it will store the informations, right? So storing and retrieving can be done with this ICs. So this and this ICs can also be analog or digital. Suppose if you are going to store the information in analog, they will be stored in the form of charges. Okay, so for that you will use BJT, bipolar junction transistors, or any UJT transistors. Suppose if you are going to store the data in digital form, MOSFETs are used, metal oxide semiconductor field effect transistors. Okay, so these are some examples for analog SRAM, DRAM, and Intel NOR flash memory chips. So next we have seen what is a microprocessor. So microprocessor is a digital chip which is a standalone chip where the other devices are connected. So this is the heart of computer, because this is an FPGA product. So this can perform multitasking. Multiple applications can be run over this microprocessor. So a microprocessor, the main function is it fetches the data, decodes it, and executes the command at the rate of 10 to the power of minus 6. So that's why we call it as microprocessor. So this microprocessor chip is the heart of computers. So this is the IC which is uh, installed, which is inside our laptop, desktop, everything. So it is a standalone device. Otherwise, it is called as the motherboard, where the external devices are interfaced. Okay. So next we have seen what is a microcontroller is. So a microcontroller is again a standalone device where all the peripheral components are fabricated in a single chip to perform few tasks. And we also discussed what are the types of wires used. So normally in microprocessor, we will use general purpose wires, and in microcontrollers, we will use RTOS, real time operating system. Because why? The decision should be taken real. At real time, it has to take the decision. All the critical analysis should be done by the processor. So that's why it is called as RTOS, right? And we have also seen the communication ICs. So example for communication IC is a modem IC or a GPRS ICs, everything. Okay. So this IC falls under mixed signal IC, because it has to process both analog and digital data. And we have seen how this mobile communication exhibits. So from the mobile, from one end to the other end, how the frequency spectrums are divided, and how the packets are converted, and how the frequencies are established from one side to the other side by saying the frequency numbers, like +9, 1, +6. So it automatically, the mobile substation will understand from which frequency the data is received and how it should be routed to the other side. So, and we also seen what are the components or the working methodology involved in a mobile phone. Okay, so whatever we speak is analog, that should be converted to a transducers. From the transducers, the electrical signals are transmitted to an transmitter, and this is converted to an electromagnetic wave. So from the electromagnetic wave, from the other side, so the receiver will receive the information. We will convert this into electrical signal into analog signal using a transducer. So this is how generally the working methodology of mobile. Okay. Now next we have seen what are the internal components available in the mobile phone. So in our mobile phone, there is a component called electronic component called duplex. So this is the device which is responsible for both communication. It can transmit or it can receive the data. And we have seen what is a baseband analog processor. The responsible of this processor is to convert the high frequency signal into baseband, which is the baseband signal is which is the signal which can be heard by the humans. Okay, so normally when you are going to transmit the information via spectrum, you have to increase the frequency range. Okay, so that frequency range can be segregated using this processor, and this can be given to the inside. And the reverse is also possible. Okay, so once if you're going to speak something, or if you're going to transmit audio or video, so it should come via a codec. A codec is an electronic device which will do the compression process. Once compression is done, it is converted into the normal baseband, human band, into high frequency signals, and then it is transmitted via a transmitter. So this is the general flow how a mobile will work. So next we have seen the level of integrations in IC fabrication. So the first IC fabrication is called as small scale integration, SSI. Okay, so we have seen this like in an IC, we have seen already. In an IC, you have a discrete components, right? Okay, if this IC contains only, sorry, if the IC contains only 1 to 100 components, okay, 1 to 100 components, The process is called as small scale integration, SSI. Okay, so all digital ICs will fall under small scale integration, right? In medium scale integration, the total number of ICs that can be accommodated in a single chip will be 100 to 1000 components. Okay, so you have multiplexers, arithmetic circuits. So this will come under medium scale integration and large scale integrations. So large scale integration, 1000 to 10,000 components. A 4-bit processor, digital calculators will come under large scale integration. So we have seen level of integration is how many number of transistors or how many number of components that are miniaturized inside a chip. Okay, that is called as level of integration. And coming to VLSI, very large scale integration, a very predominant integration scale existing right now. Okay, almost all country are using this VLSI technology, where 10,000 to lakhs of components are fabricated in a single chip. For example, you take your smartphones, embedded systems, computers, everything will be in VLSI technology. Yes.
So when we are talking about very large scale integration, now almost all nowadays devices are falling in the category.
Yes, yes, yes.
How about the electronic calculators that we are still using?
They use this large scale integration. Large LSI they use.
So now our surrounding devices that we have is a combination of LSI and VLSI.
Not all, because VLSI have thousands of transistors. It depends upon our application. Okay, suppose if I fit this VLSI chip for a digital calculator, you are wasting your resource. Yes, you are wasting your resource, right?
We are for car now, electronic cars that we are having now. Is it mostly of VLSI?
Yes, definitely VLSI, because you'll be performing lot of application, because GPRS tracker will be associated, right? So communication ICs will also be required, as well as we will do multitasking, like we will watch movies or we can hear it, you can call, lot of functions are associated, right? So there you can use VLSI chip. VLSI chip. And yes, it's always based on purpose. The next comes ultra large scale integration. So millions of components in a single IC. Okay, so this is um, process. This is the integration technology which is used only by the Japanese people. Only by the Japanese people. The Southeast East countries and even Americans, they are using only VLSI. Only. Yes, yes. Still it is in research, because research, and also the fabrication process is different for ULSI. So VLSI, they have some standard for fabrication methodologies, but ULSI, this is the standard only Japanese people using now, because yes, they have started, and the mobiles available in Japan, they are using this ULSI chip. Very expensive. Fabrication process is also very expensive. So normally, if a country is starting any semiconductor industry, half of the economy has to be put on for semiconductor industry alone. The huge investment, very, very huge investment. Yes, yes, you have to invest. And giga scale in the, you cannot imagine. So after maybe 2050, okay, 2050, we will be in giga scale integration. Maybe another 25 years to 30 years, we will achieve at least ULSI. At least we will achieve ULSI. Still, this is in conceptual only. Another 20 years. If because economy is not that strong in India, right? So maybe it will take time, but a lot of one fabrication unit they have started, it seems, in, but it is under proposal. Constructions have not ULSI, VLSI. Yes, VLSI.
That means India just started by
Yes, just started.
Malaysia, wait, haven't even begun yet.
No, yes, in Penang they
So
have.
outsourced
Yes, it has already started. They are fabricating.
natively built in India. We are talking about homemade.
Yes.
Where was first VLSI fabrication began?
Japan.
Japan itself, again Japan.
Yes.
And from Japan, you went to
Texas, that is United States,
United States.
and then to China.
Okay.
So all the technology evolves only in Japan.
Japan first. I see. But they don't seem to be dominating the market in comparison.
Because their rates are higher.
I see. So now, like India,
But whatever technology evolves, we will borrow from them.
but they still hold the IP.
Intellectual property will be held by the Japanese.
Will be hold by the Japanese. That means
Def-
every year you'll be getting certain amount of cut
yes,
from
yes,
America,
yes,
from
yes,
China.
yes, definitely. We will go for an IP and secure, right? So, so with that, we will conclude the presentation. So, A is red, B is orange, green is C, and E is yellow. I mean, D is yellow. Okay? Yeah, first question. An IC designed to amplify a continuous signal is classified as IC designed to amplify a continuous signal, whether it is a digital IC, analog IC, mixed signal IC, linear digital IC. B, because continuous signal, continue, analog. It is not a yes, discrete. Okay, okay. A mixed signal IC contains only analog component, only digital component, both analog and digital component, only memory units. Yeah, everyone get a star. Okay, we will continue. A flash memory is an example of analog, power IC, memory IC, or sensor IC. Flash memory. Flash memory is to store data. Yes, it's memory IC. So, okay. What type of IC is typically used for audio signal processing? Audio signal processing. Audio signal. Yes, audio signal is natural. Whether it is analog IC, digital IC, VLSI IC, flash. Yeah, it is analog IC. Next. The full form of SSI in IC classification is small system integration, super scale integration, small scale integration, single scale integration. Yeah, correct. It is small scale integration, right? And what is the typical gate range for medium scale integration, MSI? Whether it is less than 10 gates or 10 to 100 gates, 100 to 1000 gates, more than 1000 gates. SSI, MSI, LSI, VLSI. Now we are in, we are in MSI, the second one. Second one. Yeah, B, 100 to 10 to 100 gates. Okay? Yeah, that's all. We also saw the design flow, how an ASIC will take. So in this we have discussed about the design requirement. So what is the specification requirement? And then, so nothing but suppose, so for example, if you're going to cook nasi goreng, right? What are the components requirement? What are the raw material requirement? Okay. So you will put a floor plan, right? Architectural plan. So that is called as the design requirement. So what design are we going to design? So what are the inputs? What are the components requirement? So everything will be decided at this phase. So once this is done, we will go for design entry. So this is the application development side where we will use VHDL or Verilog. Okay, so those languages will be used to enter our application. So after converting into this, we need to check whether the functionality meets, whether the desired output obtained. So that part we will call it as a simulation. Once simulation is done, we need to convert. Until then, this is software. We really need to convert those code into hardwares. Okay, so the process is called as synthesis. So in the synthesis process, we will convert the software into hardware, and we saw what is the place and route, interconnectivity, everything will be done. So once this is completed, we will convert the bit file into the system.
Do you need like a lab for
Yes,
AVL
yes, definitely you need a system.
when we say lab synthesis tools, what kind of tools are
These are integrated design tools, will be coming in a pack.
like something designed like
Yes, design like that. Yeah, we will come to a conclusion part now. So our objective of this presentation, we have seen what is an integrated circuit, and we have demonstrated how an fabric IC is fabricated. Followed that, we can able to understand what is the difference between an ASIC and FPGA flow, and we have done ice breaking session also. So I think I can able to correlate the learning objectives with my conclusion, and I hope everyone understands. I hope everyone understand the difference between the product methodologies of FPJs and ASIC. Is it correct? Yes. So everyone is now able to categorize the product in terms of ASIC and FPGA, right? So we have seen the FPGAs or general purpose, and ASICs or special purpose ICs development. And followed that, we have discussed the classifications of ICs based on the input signals, like the input signals are analog and digitals. So we have in that we have seen the categories of digital ICs. Everything was demonstrated using an real-time applications, right? And we have seen the analog integrated circuits where this mixed integrated circuits are used, and followed by that we have discussed about the microprocessor, memory elements, microcontrollers, and communication ICs. And we also touched what are the importance of IC fabrication in Malaysia and its growth rate also. And we also seen how a product is prototyped using FPGA through FPGA design flow. For each and every session, we try to facilitate the learner using MCQ, and we had the ice breaking session also. Can I have some feedback about the ice breaking session, or some other comments also welcome to us? Yes.
for me it is very very informative, and I understood from the top level the importance of semiconductor knowledge and chip design. design knowledge and how it becomes compulsory for every engineer to, I mean, from the electrical, electronics, semicon sector to master all this to stay relevant. Otherwise, not having this is equivalent to be merely an engineer who a gatekeeper but not a designer. That's the way I look at it.
So because we in this era, everyone live with electronics. Yes, so we should know some basic informations about the ICs. So anyone? I have a question. Yes. How you are going to incorporate electronics with other fields in engineering, especially mechanical and computer science? Yeah. Give me one example. Yeah. If you take a CNC machine, CNC machine, so you have a plotters, right? So this plotters will be run through a stepper motor. So externally, this stepper motor and the machine control, everything will be done using the microprocessor or microcontrollers. Okay, so this stepper motor and its associated program should be done using the FPGAs.
They have their G code that is gone through these microprocessors and is transformed into the output.
Yes. So in almost in algorithm cryptographies, right? So cryptography is nothing but secured information. If you take military applications, so all the datas are encrypted. If you take WhatsApp, the communication is encrypted. Encryption is the raw data will be converted into non-readable format. Okay, so for those processes are also done by the encryption ICs.
So the concept of rudderless car, the car that doesn't need any driver.
Yes. Yes, yes, yes.
So the concept is the same.
Yes, definitely. Robotics. So, yes. So without electronics, there is no field. Without electronics, there is no field nowadays.
So electronics devices is a data center.
Data center. Yes. Yes, big data analysis. Almost all application falls under this. So, yeah. For me, I enjoyed the session very much. Alright. For me, it's very beneficial, especially when I'm interested in interdisciplinary teaching, because I have got students from engineering, I have got students from what you call this doing chip designs as well, and it's so very very important for me because I can now understand, right, what are they writing about when they produce such technical documents, right, for me to read or as part of our classes as well, right. So now, and another thing, as an education, what do you call this, lecturer, as an academician, I also need to be very proficient in multiple fields, right, so that I am employable and remain relevant in the industry, so that I'm adaptable to the many changes that the nation is going through. So this information will definitely help me in the long term. Sure. Remaining employed. Okay. Thank you. So thank you, Doctor. I learned so much. Your session was valuable. It was easy to understand. And I can even use some of this information here in my classroom assessment, where I can give my students, because I'm teaching technical communication, professional communication, so I can get them to write process essays, reports in areas specializing in this, and we will be, and I will understand, finally understand what my students are contributing, what they are writing about, because I know what the processes are. So thank you. Thank you so much. Thank you so much. Thank you so much. Thank you. Yes. As a former student of computer system engineering, learning FPGA design techniques and introduction to IC gave me some information that I really enjoyed, where blending hardware level control with real-time flexibility sharpened my logical thinking and deepened my passion for designing smart, efficient electronic systems from the ground up. So this background is especially beneficial to me now, as I often engage with individuals and clients from similar technical fields, allowing me to connect, communicate, and collaborate effectively. So thank you so much. Thank you. Thank you so much. Thank you so much. So I'm so happy that I can able to provide some technical information regarding IC. I can able to map my learning objectives to fulfill my presentation. Thank you so much. Any other? Yes. Okay, I enjoyed this training. I really learned so much from FPGA to S6 to types of ICs, and I love the analogy. All analogy give related to real world. Yes. So it's easier to understand. Yes. And also all your example we give from what we use regularly in our routine life. So for me, you are so good in explaining, and I learned it. I enjoy learning. Yeah. So actually, whenever we remember any concept, so we should uh, remember everything in terms of analogy so that you can remember the concept in long term. So that is the idea. I have incorporated a lot of analogies for each and every portion, so that if you see a product, you can able to correlate the analogy. So suppose if you go to restaurant, from now on, you will remember, oh, we have come to restaurant. So ma'am taught me it is an FPGA product because multiple options are available, and how to, so from the multiple option, how I pick the materials, everything. So when we cook in the kitchen also, this will come to your mind. Oh, we are doing some ASIC part. Okay. So when you go to a lift, when you turn on a TV, when you turn on your refrigerator, everything, no, you will come to realize. So some electronics is hidden inside. Just give you example of the lift. Yes, yes. If you out, yes, that's it. So whatever you press, it is an unstable multivibrator. There is a transducer that converts into a command to the processor, and the processor will take the intelligence decision where the flows to be go, and it should come. Okay. And also in the washing machine also, we have seen what type of processor it is used, how it is activated, and how the functionalities are performed, right? And even in the communication sector also, we have seen how mobile communication is established between end to end user. So I have specified the numbers. If you type some numbers in your mobile phone, now on you will remember, this is not a number, this is a frequency. Okay. So the first two digit you can able to understand, this is a country code. So why? Because this is very important nowadays, right? This country code is important because every communications are done using this frequency ranges, right? Okay, thank you so much for your questions. Thank you so much.